Well, you're here at a WebAssign question that involves pH, hydrogen ion concentration, pOH, and hydroxide ion concentration. Before we go any further, let me indicate that pH is really an important value that is used in all sorts of industries, especially the food industries. If you are working professionally at all with foods, you have to know about pH. Now, pH is measured pretty quickly and easily. All you've got to do is buy a pH meter. And also I have some solutions to test. Here's the least expensive pH meter I was able to find, about $12 on Amazon. And you can see they've got this submerged in some water, and they've got a pH that's listed here at 5.33. And here they're saying you can use it to test for water, measuring swimming pools, drinking water, aquarium, and food. If you're canning anything, you have to know the pH. And here's the other part of the ad, which is nice. It shows you the range of numbers you get with pH. A 0, which is pretty extreme in terms of being acidic, and then up to 14, where we become alkaline. You can get all these things at a hardware store, but here's other things that you would be interested in terms of finding the pH of. In fact, here's one that we're using for this problem right now, black coffee, and also we'll be having tomato later on, and we'll include ammonia solution, so our choices are pretty good. As I said, this is an inexpensive one, about $11. Commercially, you want to use one that's professional, that you can be certain of. Here's a Hannah, which is about $700. It's set up for temperatures, and it's got, down to 1,000th of a pH. This is a pretty accurate measurement. It'll actually give you 3 significant digits in terms of the quality of acid. They're pretty sensitive. If you wave your hand at one of these things, and it's like Ghostbusters. It'll take off. And it takes quite a bit of training to be able to use these effectively. In fact, you'll notice here they've got a stand to hold it. You'll probably have a stir bar too. And if you've got a few extra dollars, you can spend $4,000 for this Mettler that, again, will send out data so you can be certain of it. But getting this number, it's a nice simple number. I mean, typically, as they showed here in this example, your numbers run from 0 to 14. And in fact, if you get a p-value other than that, you know you're doing something wrong. So numbers are 1 to 14. If somebody asks for, what's a pH in an answer, if you get less than 0, you know something's wrong, and more than 14, double check. So let's go here to coffee. Now, we'd have to wait for this coffee to come to room temperature to really get an accurate pH of it, unless you've got a fancy one that can adjust for temperature. Now, we're going to presume these are all at room temperature, 25 degrees Celsius, because pH changes. In fact, even neutrality changes with the temperature of water. But that's another story. So if you've got a pH of 5, the real question is, what does that mean? Well, it means that it's got a certain amount of acid and base in it. We want to know what that is. And that's what this question set up. What is the concentration of the H+, the acid component? Water decomposes to make H+ and OH-. How much H+ do we have in this coffee? Well, go to your summary. And here in your summary at 15.3, is the answer to all of your questions. It tells you exactly how to convert pH into hydrogen ion concentration, and how to take hydrogen ion concentration and convert it into pH. In fact, I've got to go back and make this a superscript plus. That's something that should be put in there. This could also be H3O plus. This is something that you should remember. Now, it looks like it's complicated because you've got, all these things, but really notice that the p-values are just the negative log of any one of these characteristics. And the way to get the number back is just raising to a power 2. So let's go back to our problem and see if we can solve it. H+. We have the pH, and here was the solution. If you want to find the actual concentration in terms of molarity, take 10 and raise it to the negative value of the pH. Now remember that negative, because otherwise you're going to really mess things up. You'll get thousands instead of thousandths. Well, the answer to this is 10 raised to the negative 5, because we have a pH of 5. So I'm going to get my text box out here and just type this in as I would on WebAssign. Instead of saying 1 times 10 to the negative 5, I'll just type in 1. In fact, I'll put a 0.0 here. WebAssign really likes 3 significant digits, but this is going to work out evenly. And then I'll type in my exponential entry, which is what WebAssign likes, E, and then negative 5. Of course, you know that is 0.0000. I mean, we've got 4 zeros and then a 1. 10,000th molar. In fact, oh, wait a second. Concentration is in molar, and I've got to write that down. pH doesn't have a unit. Again, they're trying to make pH simple so that anybody can quickly use it. If you can type in a simple number from 0 to 14, you can figure out what a pH is. And that's the reason for pH. pH was made to simplify acids and bases. So we know this answer is decimal point 0.0000, 4 zeros, and then a 1. Or it's a lot easier to type in 1e negative 5. Or if you're doing this on an FRQ, 1 times 10 to the negative 5. There, this number in front of the decimal point becomes the exponent. So the pH becomes the exponent of 10 with that negative value. And if you don't put the negative in there, you're going to get 10 to the 5, which would be 10,000. And the acid concentration is not 10,000. Well, let's find the pOH. What's the pOH? You don't hear that much about it, but it's a useful number, and it'll help you solve problems. Now let's go back to our little chart here and find out about pOH right here. Notice that pH plus pOH for water at 25 degrees Celsius is 14. The pKW for water is 14 because the ionization constant, the acid concentration, H plus, times the hydroxide concentration in water, no matter what type of solution it is, at 25 degrees Celsius will always equal 1 times 10 to the negative 14. And I guarantee you will use that relationship many times on the AP exam. If you don't, you're not taking an AP exam. Turn it in. It's a fake. You will be using this consistently, and it's expected that you know that value. So let's go back to our problem. We know the pH and pOH add up to 14. Well, that's going to be pretty easy here. I'll just say 5 plus, and let me get my text out. 5 plus 9. I'm going to put 9 here and get rid of my italics. That's the pOH. No unit for pOH. They both add up to 15. 14. 9 and 5 add up to 14.00. And again, I'll just leave this as 9.0. It's one significant digit. Now, the hydroxide ion concentration means here, let me pull this down because this is at 25 degrees Celsius. The pKW for water is 14. At higher temperatures, it's lower than this, and at colder temperatures, it's higher than this, and you'll be learning more about that. So they add up to 14. That's why we like the pOH. It's simple, fast, and easy. But now I want to know, what's the concentration of the base here? Because water is going to have both hydrogen ion concentrations and hydroxide ion concentrations. They are both there. If the H plus is high, then the OH minus will be low, and vice versa. So let's go back to our calculation, and you probably don't have to because you know that p-values are exponents of 10. So all I have to do is say, okay, this is 10 to the negative 9. So I'll go back here, and I can just type in text. I'll type in 1, and then again, I'll use my scientific notation and my notation that WebAssign likes, and you would use times 10 to instead of using the E notation. And don't forget -9. This is a decimal point, and this is a molar concentration, so I'll get my italics and type in M. And let's get that out. So we have molar. I mean, this is a minuscule concentration. The hydroxide concentration is going to be in the area of certainly a billionth molar, while our acid concentration naturally is going to be a little bit higher. It's going to be up to, in this case, about a 100,000th molar. So they both add up to 10 to the negative 14, or multiply out to 10 to the negative 14. So that's it. This is the method that you're going to use all the time for pH and pOH. There's a number of different ways of doing it, and in this case I used the pH to get the pOH. Then that gave me the hydroxide ion. There's another way of getting the hydroxide ion quickly, but that's another problem. So there's a little summary of pH. And by the way, the pH of coffee is pretty critical, though. And actually, when it's hotter, the pH is lower. That's supposed to adjust the flavor a bit. That's why hot coffee tastes a little bit different than cold coffee, because as it cools, the pH changes because the pKw changes. Oh, okay. There's our coffee at room temperature, and its hydrogen ion concentration and its hydroxide ion concentration, which go hand in hand.